Today I'm going to be dealing with logarithm. So logarithm refers to a power that when given that is raised to a base in order to get a particular number. For example, if I have log of log base 2 8, now what kind of power can I give a 2 in order to get 8 is what will be my answer here. Sort of that if I have the log, for example, I have 2 times 2 times 2, this gives me 8, and therefore this is 2 to the power 3, of which this is the power I can give it to in order to get 8, and therefore my answer here would be 3. So the most property that we are relying on here, you find that if I have log of a, b giving me a c, that I would raise a power c giving me a b. That's why they say the base, the power that's given to it, is the one that gives you the particular number in that case. So for example, if I have another example, I have log 5, I have 6 to 5. So you find that this one I'll have 5 times 5 times 5, which would give me 6 to 5. But in this case, you find that this itself, I would have here log, this is 5 to power, times 5 here, and therefore this would be 5 to power 4, which would be 6 to 5, and therefore the answer here would be 4 in that case. Sort of that, this is how I can explain logarithm. Maybe better you can easily understand it. So out of that, if I have the log of 10 but I have 1000, what power can I give the base in order to get 1000? So you find that I might come here, say 10 times 10 times 10. Yes, this would give me the 1000. Awesome. But after giving me 1000, but we find that this is 10 to power 3, and this would be 1000. So that means that log base 10 1000 be equals to 3 in this case, of which sometimes if you're working out, you might write that log of 10 1000 would be equals to log of 10, I'm having 10 times 10 times 10, and here I would have something that would be log of 10 power 3. So you take this here where it will meet a 1, and therefore you have something 1 times 3 log of 10, and then you find that now if the base and number there are the same, you find that you get a 1, and therefore this should be 3 in this case. So you find that they all bring out the same meaning. So if I have, for example, log of 2, which would be equals to now what power can I give a 10, this 10 down here as the base, to get 2 in this case? So if I out of that, this would be 0.3010. so this is the power that, so you find that if I say 10 to power 0.3010, this would give me a 2, taking us back to the above expression whereby we had log of a, b equals to c, that a to power c, b equals to b. So you find that this is how we can easily interpret this. Let's try to understand the elementary rules for logarithm. That if I have log, of let's say to base x, I have a, b would be equals to log of x a plus log x. Now, to prove this is that to prove that this is true, we are going to say that let log of x a be equals to k, and therefore we are going to have, this is going to be, remember, x to power k would be equals to a, and out of that you find that make this as my 1, and then I also let log of x be equals to let me get another letter, this is m, so x to power m would be equals to b. So out of that, to get this, I'll come here and proceed by, I would say that this is 2. So out of that, if I multiply, for example, I get this expression back, I multiply a and b. So out of that, I'll come and say a times b, which would be equals to, I'd have x to power k times x to power m, and this would be equals to x to power k plus m, and therefore if I'm having, that means that AB is the one that's equals to that. Now I introduce back the logarithm, but having the base of x, so I'm going to say log of x AB equals to log of x to power k plus m. So this x will cancel with this, and therefore I'm going to have log of x AB, which would be equals to, this would be k plus m, and therefore I'm going to have, this is log of x AB would be equals to, now I had previously k and m, so k was log x a, so plus log, this is base x but b in this case, so that's why you find that, that's why this is equals to this. But you may be asked to prove that log base x ab is equals to log a base x plus log b base x, so you just prove it. Now let's go to the second elementary rule. If I have log x a out of b, this is going to be equals to log x a minus log x b, and therefore from there I'm going to have something that's going to be, I say let log x a be equals to, let me use k also, and log x b equals to m. So to work out this, what I'm going to do, so from the first one, if this is my first one, this is the second, so out of that I know that x to power k be equals to a, and from this one is from the first one, and from the second one I know that x to power m would be equals to b. This is from the second one. So of that, my expression would be that I would have something that would proceed like this. So I try to attain this, and so if we try to bring back, and you say we bring back this, so this is going to be a all over b, which would be equals to, I'm having my a, so this would be x to power k all over x to power m. Therefore we're going to have this to be x to power k minus m. Now let's introduce the log to the base of x again. So log of x a all over b, close this. This should be equals to x, this should be log of x power negative k minus m, and therefore we are going to have log of x a all over b equals to half k minus m. Instead of that, but we know k and m. K is this and m is this, so that this would be log of x a all over b would be equals to log of x a minus log of x b. So this is how you can prove this expression. So let's look onto another expression. If you have log, I have log of x a to power n is equals to, we are having n log of x a, and therefore to prove this we are going to say let k be equals to log of x a in this case, and therefore we are going to have here, this is going to be x to power k be equals to a, and therefore now let's multiply the power on both sides by n. So this is going to be x to power nk would be equals to a to power n. Now let's introduce the log to base x. So we are going to have here, this is going to be log of x to power nk, which would be equals to, I'll have log of x a to power n, and so this is going to give us nk, which would be equals to log of x a to power n. But we know what k is. K is this, so n log of x a be equals to log of x a to power n. So this is how you can prove the above elementary rule, that n log x a is equals to log x a to power n. Now suppose we have another elementary rule, that if I have log of x a would be equals to 1 all over log of a x. So how would we prove this? So let log of x a be equals to k, and so we are going to have x to power k would be equals to a. So let's introduce the log of a. So we are based on the base that we are having final. So log of a x to power k would be equals to log of a is, so out of that this is going to be k log a x would be equals to 1. And so when we proceed with this, we are going to have k equaling to, we're going to have 1 all over log of a, but here x, but we know what k is, so therefore we're going to have log x a would be equals to 1 all over log of a x. Therefore this is the proof for the above elementary rule. Let's try another one. Suppose you have log of x. We're having p. This would be equals to have log of p base c all over log of x base c. For this, we are going to say that let log of x p be equals to m. So you can choose any letter, but I'm using common letters. So you find that this is x to the power m would be equals to, I would have p in this case. So that having got that, now I introduce the final, let's say, base, of which this is going to be log of c x to the power m be equals to log of c p. So out of that, I'm going to say this is m log of c x would be equals to log of c p. And so I'm going to have m equal to log of c p all over log of c x. But we know what m is, and therefore we are going to have log of x p is going to be log of c but p divided by log of c x. And therefore this is the proof for the above elementary rule of logarithm. Now let's try one more. Prove that log x nth root of m is equals to 1 all over n log of x m. So to prove this, what we are going to do, we know that, but this, if you look at this is the same as someone having log x m to power 1 out of n. Now, having known that this is like this, so what we are going to do, we're going to say let log of x m be equals to, let me use k in this case. So out of that, we are going to have x x to the power k would be equals to m. Now let's multiply the powers by 1 all over n. So this is going to be 1 out of n, and this is going to be times 1 out of n. So we are going to have something that's going to be, we're going to have x to the power 1 out of n, but this is going to be k equals to m to the power 1 out of n. Now the next step is to introduce logarithm. So we are going to have something that's going to be, we're going to have log x x to the power k out of n equaling to, I'm going to have log of x m to the power 1 out of n. So this is going to be k out of n, which would be equals to, I'm going to have log of x m to the power 1 out of n. And so, but we know what k is, therefore 1 out of n, k is something that we had here. So log of x m, which would be equals to log of x m to power 1 out of n. Therefore, in initial form, 1 out of n log of x m would be equals to, we're going to have log of x nth root of m. So this is how we would prove the above elementary rule of logarithm. Now let's try to solve some equations using the elementary rules. Log of 5x plus log of x, here we're having 5 is equals to 2.5. So out of that, here we're seeing that we are having different bases, and we can express one base to another base. So we choose which base we want to be common. So out of that, if I choose 5 as my base to be the base throughout, so I'm going to come here and say that this is going to be log of 5, log base 5 x plus, I'm going to have, this is going to be log of, so our base is 5, so this is 5 all over log base 5x is going to be equals to 2.5. And therefore what we're going to have here, this is going to be log base 5x plus, this is going to be 1 all over, this is going to be log of 5x is equals to 2.5. And so if we look at this, if we multiply throughout as our LCM, so we are going to have log of 5, this is squared, plus this is going to be 1 equals to 2.5 log base 5 of x. And so let's say, since this will result into a quadratic equation, I say let log of, let's say base of 5x be, let me use p in this case. So out of that, this is going to be p squared plus 1 is equals to 2.5 p. And so I'm going to have p squared minus 2.5p plus 1, which is equals to 0. So using the quadratic formula, I know that p equals to, so this is 2.5 plus or minus under the root, I'm having 2.5 squared 6.25 minus, I'm going to have 4 times a, which is 1, times c, which is also 1, divided by 2. Therefore this would be equals to 2.5 minus root, this is going to be 6.25 minus 4 divided by 2, and so this is going to be equals to 2.5 plus or minus the root of 2.25 out of 2. Which would be proceeding as, would have 0.5 positive or minus, so we are going to have 1.5 5 all over 2. Therefore either p would be equals to 2.5 plus So plus 1.5 all over 2. And this would give us a 2. And for the OR part, P would be equals to 2.5 minus 1.5 all over 2. And so this would give us 1 all over 2. And therefore these are the values of P. But remember, P had its own expression, and therefore if P log of base 5x would be equals to, now we have the values. For example, we're having 2, we got this and this, therefore we're having 2, so 2, and also log base 5x was equals to 1 out of 2. So that, let's get the two values of x. So out of that, we know that 5 power 2, if this is the first one and this is the second one, so this is going to be 5 to the power 2 would be equals to x, and therefore 25 would be equals to x. Also, if we have from the second one, so we have 5 to the power 1 out of 2 would be equals to x. That means the root of 5 would be equals to x of 2.23661, and this would be equals to x. So this is how you use the elementary rules of logarithm to solve an equation, but you have to be conversant with quadratic equations. Now let's try another example. Now suppose you have 0.3 to the power x plus 1, that this would be equals to 0.7x. So out of that, to work out this, use logarithm. So out of that, if I say, now if you don't have logarithm within, let's like your question, the logarithm that you would introduce is to base 10, and therefore log base 10 of 0.3 but to power x plus 1 is equals to log base 10 0.7 per x. Now even if I write this minus without showing the base, it means that it is to base 10. Therefore this is going to be x plus 1 log of 0.3 equals to x log of so 0.7, and make them the same. So this is 0.7, and therefore I want to get the value of x. So that if I work out this and I also work out this, so let me put this in the bracket, and therefore 0.3, so this is going to be x plus 1 into negative 0.5229 would be equals to x into, this would be negative 0.1549. And so this would be negative 0.5229 x minus 0.5229 equaling to, I would have here, this would be negative 0.1549 x. And therefore, let's collect the like terms. So you find that I'm going to have negative 0.5229 x plus 0.1549 x, which would be equals to, now let's take this on the other side, this would be 0.5229. So that by working all this, this would be negative 0.3680. X would be equals to 0.5229. So divide by negative 0.3680 by negative 0.3680. And therefore, my x in this case would be equals to negative 1.4209 as the value of x. And therefore, this is how you would work out such an example. Now, let's try another example. If you have 0.1 power x is equals to 0.2 to power 5. Now, out of that, let's introduce logarithm. So I know that log 0.1 power x would be equals to log 0.2 to power 5. And therefore, I'm going to have something that's going to be x log of 0.1 be equals to 5 log of 0.2. So out of that, having got this is log. So to get x, I would say that this is equals to 5 log 0.2 divided by log of 0.1. And therefore, here I'm going to get something that's going to be x equals to 3.4949. Therefore, this would be the value of x in this case. So let's continue with another example of 2 to the power 3x plus 1, that this would be equals to 3 to the power x plus 2. So this should be, if we introduce logarithm here, find that I'm going to get something that's quite familiar. So I'm going to say that if I have I'm going to have, if I introduce, so this is going to be 3x plus 1, close this, log of 2 be equals to x plus 2 log of 3. Therefore, this is going to be 3x plus 1. This is going to be 0.3010 equal to x plus 2, close this, 4771. And therefore, 0.9030 x plus 0.3010 equaling to 0.4771 x plus 0.9542. And therefore, the next thing here, I'm going to collect like terms. So 0.9030x minus 0.4771x would be equals to 0.9542 minus 0.3010, and therefore I'm going to have the 0.4259 x, which would be equals to 0.9 b 0.6532. So all over 0.4259 over 0.4259. So x would be equals to the 1.5362. And this is how we can work out this example. Let's try one more example. Now, if you have a ln of x plus ln e of x to be equals to 8. So we know that this would result into x plus x, which would be equals to 8. Therefore, 2x would be equals to 8. Therefore, x would be equals to 8 divided by 2, where x would be equals to 4 in this case. So this is how we work out such an example. Thank you for watching. If you like the video, give it a thumbs up. Don't forget to subscribe and share. See you next time.